Welcome to ASMTower software. In this example, you will learn how to design a 30-meter monopole with a dual platform and carry GSM antennas and microwave dishes. Open the Geometry group and then open the Pole Parts group to open the Taper Pole dialog box. Some initial dimensions of the monopole will be assumed. The first bottom will have a zero overlap. As we define the overlap between the current part and the lower part. The overlap length is defined by this function. Overlap equals A times bottom diameter plus B. If the length of the overlap is known, parameter A must be set to 0, but parameter B is equal to the length of the overlap. For a new monopole design case, where the length of the overlap is not known, parameter A is 1.6, and parameter B is 0. For a monopole case with a flange connection instead of overlap, set the parameter A and parameter B equal to 0. The monopole profile may be cylindrical or polygonal, with 8, 12, 16, 18 or 20 sides. In this example, a polygon with 18 sides will be used. You may assume any primary dimension for the monopole, and this will be modified later based on the stress rating. Assuming the bottom diameter is 1200 mm, assuming that the top diameter is 500 mm, assuming that all parts with a shaft thickness of 5 mm. Let the bend radius equal to 0, so the software will assume its default value in the design. Assuming that the materials available in the factory are of European standards. The use of high tensile steel for a monopole shaft is usually an economical option. Therefore, we will choose S355 for all parts. Check this option and set the target height equal to 30 meters. Click the Calculate Missing Data button. Now ASMTower calculates lengths of all parts assuming equal lengths. Preferably, part length shall not exceed 12 meters for easy transportation. It is sometimes preferred not to exceed 11.8 meters to allow shipping through containers. Click Update to allow ASMTower to update the entries and refresh the graphic. As you can see, the monopole is drawn. Select profiles that will be used in the ladder and the platform. To do this, open the Selected Sections Entry dialog box from the Geometry group. Choose the European standard in the Material standard. Choose S235 as mild steel. Set the section type as an equal angle. Choose the European standard in the Profile standard. Choose the 60 by 5 angle to use as a ladder rail and click Add. Set the section type as a pipe. Choose the 76 by 4 pipe from the European standard to be used as a platform rail and click Add. Set the section type as solid round. Select the rod 20 of the European standard to use for the ladder steps and click Add. Select rod 10 to be used as a safety wire in the ladder and click Add. Click OK. To define platforms, open the Platform Entry dialog box from the Geometry group. We will define two platforms at the level of 29 meters and 25.5 meters. Type a name for the highest platform at the level of 29 meters. The elevation is equal to 29 meter. Set the platform type as circular. Set the face width equal to 2.5 meters, and that is the diameter outside the platform. Vertical members are members used to carry various rails in the platform. Set it equal to 6. Assume the thickness of the plate in the deck is equal to 5 mm. This will be used in calculating the weight of the deck. Click on the Horizontal tab. First, define the handrail, followed by knee rail and toe rail. Choose a 76 by 4 pipe that has already been added in the Selected Section dialog box. Set the angle of the twist equal to 0. Vertical offset is the vertical distance measured from the current horizontal elevation and the platform elevation that was set to 29 meters. At least one horizontal shall have a 0 offset equal to 0. Set a vertical offset of 1.2 meters for the handrail and 0.6 meters for the knee rail. Click the Support tab to define the vertical members. Choose a 76 by 4 pipe and a twist angle of 0. Click the Add button to add the current platform to the list of platforms. Rename the platform to define the next platform at the level of 25.5 meters. Set the elevation to be 25.5 meters. All other parameters remain as specified in the previous platform, and click the Add button. Click the Add button to add the current platform to the list of platforms. Click Update to allow ASMTower to update the entries and refresh the graphic. 2 platforms appear in the 3D view. It was also added to the design drawing of the structure. In the next step, we will define the antennas. Click the Panel antenna from the Appurtenance group. Start by identifying the antennas in the upper platform. Assume the antenna center elevation is 30 meters to make the bottom of the antenna near the deck of the upper platform. Choose the type of antenna. Note the antenna list is still empty. To show the antennas in the list, click the Database tab at the top, and then click the Antenna Panel button. In this example, we'll show only the hexaband antenna and another one called RRU. The hexagonal band antenna has dimensions of 2600 mm height, 548 mm width, and 150 mm depth. You can edit each dimension and click the Update button to modify the current antenna, or click the Add button to add a new antenna. Click Close. Open the antenna panel again from the Appurtenance group. Add an elevation of 30 meters. Choose a hexaband in the antenna type. Choose the type of mount as pipe 76 by 3000 and set the quantity equal to 1. Open the Location Type menu and choose Platform. From the Offset Type list, choose the name for the highest platform. Choose A in the Leg or Face menu. Adjust the horizontal offset by 0.2 meters. This distance is the net distance from behind the antenna and outside the platform. Set the vertical offset to 0 if the center of the antenna is the same level as the mounting center. Set the azimuth adjustment to 0 to define an antenna with a direction similar to that of the face A. Adjust the tilt adjustment equal to 0 to make the antenna direction in the horizontal plane. Clear spacing is the net distance from behind the antenna and the face of the mount's pipe. Set it equal to 0.12 meters. Set the shielding factor Ka to 0 to allow it to be automatically calculated by the ASMTower software based on the platform type. Select the first row that we just defined, and on the keyboard, click the Control button with the C button to copy the row. Select the first cell in the next row, and on the keyboard, click the Control button with the V button to paste the first row. Paste it twice. Modify the face symbol to be B and C. Click the OK button. Click Update to refresh the graphics. You can see the 3 antennae that are defined. Click the Fit button, and then click the XZ button to see the structure plan. Reopen the panel antenna input form to continue. Select the first 3 rows, and on the keyboard, click the Control button with the C button to copy the row. Click the Control button and the V button to paste the rows. Change the name of the antenna in the 4th row to be RRU. Copy the antenna name and paste it into rows 5 and 6. Choose the type of mount as pipe 76 by 1000. Copy and paste the mount name in rows 5 and 6. Suppose 0.7 meters for the lateral offset of RRU to avoid a clash between the antenna and RRU. You can see the center of RRU is identical to the center of the antenna. View the plan view to review the position of RRU. To make the RRU away from the panel antenna, open the panel antenna dialog box and set the lateral offset equal to 1 meter. Click OK. Click Update to refresh the graphics. Let's see the effect of increasing the horizontal offset of 10 cm to be 0.3 meters. You'll need to increase the clear distance by 10 cm to keep the mount unchanged. The net distance is the distance from behind the antenna and the face of the mounting pipe. Click OK. Click Update to refresh the graphics. Let's change the azimuth adjustment to 30 degrees for the RRU. You can observe that RRU direction is rotated by 30 degrees. We will now increase the amount of RRU to 3 for each plate antenna. Click the Panel Antenna dialog box from the Appurtenance group. Set the elevation of RRU to be 29 meters. This will make it at the bottom of the hexaband antenna. Select rows 4, 5 and 6, and then copy and paste into new rows. From the keyboard, click the Control button with the C button to copy, click the Control button with the V button to paste. Select a new row and paste it again. Change the elevation in rows 7, 8 and 9 to be 30 meters. Change the elevation in rows 10, 11 and 12 to be 31 meters. Click OK. Click Update to refresh the graphics. To rotate the 3D view, click the Y+ button. Click the Fit button, and then click the XZ button to see the structure plan. Define the antennas in the second platform. Click the Panel Antenna dialog box from the Appurtenance group. Select the first 12 rows, copy and paste them into a new row. From row 13 to 24, change the platform name. The difference between the elevations of the platforms is 29 meters. 25.5 meters is equal to 3.5 meters. In rows 13 to 24, each elevation is subtracted by 3.5 meters. assure that Ka is 0 to allow the software to calculate it based on the platform type. Click OK. Click Update to refresh the graphics. Click Save button to save the file. Type any name for the file, say 30-meter monopole, 6 antenna. Click Save. Define the microwave antenna on the platform. Open the microwave dialog box from the appurtenance group. We will define tow microwaves, one at the level of 29.5 meters and the other at 26 meters. From the microwave type, select a microwave with a diameter of 1.2 meters from Andrews manufacturer. Select a pipe diameter of 76 mm and a length of 1.5 meters in the mount type. Copy the first row to a new row. Select Platform from the Location Type list. Select the top platform name in the Offset Type list. Select the face A. Set the horizontal offset equal to 0.3 meters. This distance is measured from the back of the microwave to outside the perimeter of the platform. Adjust the lateral offset equal to -1 meter to avoid a clash with the panel antenna. Set the vertical offset to 0 if the microwave center is the same level as the mount center. Adjust the azimuth adjustment to 0 to make the microwave orientation corresponding to the face A. Adjust the tilt adjustment to 0 to make the microwave direction horizontal. The clear spacing is the net distance from the microwave back and the face of the mount's pipe. Set it equal to 0.2 meters. Set the shielding factor Ka to 0 to be automatically calculated by the ASMTower software based on the platform type. Ka is used to calculate wind load at mount only and does not affect wind load on microwave. Click OK. Click Update to refresh the graphics. Click the Fit button and then click the XZ button to see the structure plan. To change the direction of the microwave, let's set the azimuth adjustment to 30 degrees instead of 0. Click OK. Click Update to refresh the graphics. You can notice that the direction of the microwave rotates in an undesired direction. Let's set the azimuth adjustment to 30 degrees negative instead of 30 degrees positive. Click OK. Click Update to refresh the graphics. To see the side view, click the XY button. To adjust the direction of the microwave towards the sky, like satellite dishes, adjust the tilt adjustment to be 45 degrees. Click OK. Click Update to refresh the graphics. Reset the tilt adjustment to 0 because in this example, this microwave is connected to another microwave and not a satellite. Click OK. Click Update to refresh the graphics. Let's see the tilt adjustment effect in the panel antenna. Open the panel antenna dialog box from the appurtenance group. Adjust the tilt adjustment so it is equal to 20 degrees. Click OK. Click Update to refresh the graphics. You can see that the antenna direction is up. To make the direction down, adjust the tilt adjustment to 10 degrees negative. Click OK. Click Update to refresh the graphics. This is the effect of using the mechanical tilt in the panel antenna. I'm going to restore the tilt adjustment value to 0 in this example. Click OK. Click Update to refresh the graphics. Click Save. Now I will define the design criteria. Open the design code data from the wind load group. Usually the following input is given in customer specification. Set the basic wind speed to 160 km per hour. Set the service wind speed to 112 km per hour. Set the maximum allowable sway and twist during service wind speed by 1 degree. This is usually input from the customer specification. Click OK. Click the Save button to save the file. Before performing the analysis, you need to add the ladder and the transmission lines. To add the ladder, open the ladder dialog box from the geometry group. Set the elevation of the bottom equal to 0 and the top elevation equal to 30 meters. The bottom radius is the distance from the monopole center to the center of the ladder at the bottom elevation. To make the ladder run out of monopole by a fixed distance of 15 centimeters, put the bottom radius equal to the radius of the monopole at the bottom plus 15 centimeters. The bottom radius is 1.20 divided by 2 plus 0.15 equals 0.75 meters. Set the bottom azimuth to 0 to make the radius specified in the direction of the global x-axis. The upper radius is 0.5 divided by 2 plus 0.15, which equals 0.4 meters. Set the top azimuth to 0 to make the top radius specified in the direction of the global x-axis. The clear width is a net distance between the main rails in the ladder. Suppose it is 350 millimeters. Step spacing is the distance between the steps in the ladder. Suppose it is 300 millimeters. Select the rail profile as the 60 × 5 angle that we previously added in the selected section dialog. Select the 20 rod for the rung or the step profile. Select the 10 rod for the safety profile to look like a safety wire system. Setting Ka value to 0 will allow ASMTower to automatically calculate it based on the ladder position. To rotate the 3D view, click the +Y button. Click the Fit button, and then click the XZ button to see the structure plan. The ladder is now drawn parallel to the monopole surface with an offset of 15 centimeters. Click 3D View. To add transmission clusters, click Transmission Lines from the Appurtenance group. Set the bottom elevation equal to 0 and the upper elevation equal to 29 meters. The radius and azimuth should be adjusted as in the ladder to make the center of the transmission cluster identical to the ladder center. In the cluster name, select a group consisting of 24 feeders, 7/8 of an inch, arranged in 6 columns and 4 rows. Setting Ka value of 0 will allow the ASMTower software to automatically calculate it based on the position of the transmission cluster. Click OK. Click Update to refresh the graphics. Transmission lines appeared in the 3D view. And then click the XZ button to see the structure plan. In the plan, you cannot see the transmission cluster as defined below the end of the monopole. To make the transmission cluster appear in the plan, change the top elevation to 30 meters. Click OK. Click Update to refresh the graphics. Now the transmission cluster is pulled to the end of the monopole. Usually, for an economical design, try to assign transmission lines within the monopole shaft to avoid overloading the wind. To do this, set the upper and lower radius to 0. Click OK. Click Update to refresh the graphics. Now the transmission cluster is drawn inside the monopole. Adjust the upper elevation equal to 29 meters, as the feeders are usually erected up to the level of the platform deck. Click the Analysis button. After the analysis is complete, click Done, and the report will open automatically. Click the Design drawing on the bottom tab. This design drawing can be saved to a CAD file by clicking the Export button. You can also print the drawing directly by clicking the Print button while choosing the Design Drawing tab. Click the design result to see a single line drawing with lines coloured based on utilization ratio. Right-click the mouse in the black screen border to choose the drawn part. Select the maximum height and click OK to see the entire structure drawn. The top part is painted green, which means it is safe. The bottom and middle part are painted red, which means it is not safe. Now the report is opened automatically. Many calculations and details are presented in the report. We will customize the report. To do this, select the setting on the top tab and click the Report button. Click the mouse next to the component word. Check on and then check off to hide all components in the report. Just check on the Summary, Panel Geometry, check on Serviceability, and the Pole Design Summary. Click the Report button to automatically recreate and open the report. The pole part rate 1.4 means that it is not safe because it is more than 1. The total weight of all parts is equal to 3.5 tons. The bottom has a high utilization ratio equal to 1.4. To reduce it, you can increase the part thickness or diameter. In this example, we will increase the diameter. Clear part diameters to allow the software to recalculate. Increase the bottom diameter to be 1,350 mm instead of the old of 1,200 mm. The upper diameter may not change because the top part is safe. Clear part lengths to allow the software to recalculate. Click the Calculate Missing Data button. You may notice that the lengths of the parts are longer than before. This is due to the increased diameters, and then ASMTower estimates the need for longer overlap and hence longer part lengths to achieve a target height of 30 meters. Click OK. Click Analysis to repeat the analysis and safety checks. Now the total weight of all parts has become 3.8 tons, but the bottom part is still not safe. However, the middle part became safe. Geometry Group, Pole Parts Group, and then click Tapered Parts. Increase the thickness of the bottom part to be 6 mm instead of 5 mm. Clear all the diameters and lengths of the parts to make ASMTower recalculate again. Click OK. Click Analysis to repeat the analysis and safety checks. Now the bottom is green and blue, and thus became safe. Show full of the monopole. All colours are either green or blue, so all usage ratios are less than 0.98. Now the weight of all parts is 4.1 tons. The structure is safe with the following evaluations. Sway is 0.91 degrees. The maximum horizontal displacement is 259 mm below the code limits. Code limits as per TIA Clause 2.8. Close the report the structure became safe. We need to adjust the position of the ladder after changing the monopole diameters. Change the bottom radius to be 1.350 divided by 2 plus 0.15, which is equal to 0.825 meters. The structure is saved by a ratio equal to 0.88. The sway is 0.91 degrees. Close the report. Click the Project Info button in the top tab. Put the project name as a GSM network. Client name ASM. Job number as 30-meter monopole 6 antenna. Designed by Joe. Reviewed by ASM. Click OK. We can now specify the base connection. Type a name such as BaseCon. Click the bolt details on the top tab. Try the anchor bolt diameter equal to 30 mm. The number of anchors is equal to 32. And use F1554-56 as the grade bolt. PCD means the pitch circular diameter, and this means the diameter of the circle in which all the anchor bolts are located. PCD can be assumed as the bottom monopole diameter plus 4 times the anchor diameter. Click the Add button. Click the anchor assembly on the top tab. The anchor length may be assumed to be 45 times the anchor diameter. Let the anchor length equal to 1300 mm. The length above the concrete should be greater than the thickness of the grout, in addition to the thickness of the base plate and twice the diameter of the anchor. RS is the maximum spacing between the anchor and the reinforcement of the foundation column. Suppose it equals 250 mm. The distance is from the end of the anchor to the top surface of the anchor head. Assume it is 80 mm. Suppose the foundation column has a reinforcement with a diameter of 20 mm, a spacing of 100 mm, and a side cover of 75 mm. The column can be reinforced with straight rods or with the J-hook. The type of anchor bolt can be smooth bar with a head, deformed straight bar, or smooth bar with an L or J hook. Check this if the foundation reinforcement is epoxy coated. Determine the yield strength of the foundation reinforcement. ACI 318 allows reducing the development length of the reinforcement by its utilization ratio. To do this, reduce the yield strength by multiplying it with the utilization ratio of the foundation reinforcement. For example, a foundation column carrying a monopole is usually enlarged in dimensions to be larger than the monopole base plate. Usage of reinforcement with a minimum ratio of 0.5% of the concrete area usually leads to reinforcement with a utilization ratio of less than 0.5. In this case, specify the yield stress as 0.5 times 420, equal to 210 megapascal. Assume the concrete compression strength as 21 megapascal. All these parameters can be rechecked after the design of the monopole foundation. You can bypass development length checks by checking this. Assume the base plate with an outside diameter equal to 1560 mm. usually larger than PCD with 3 times the anchor diameter. Check on the use of grout and levelling nut. It can be assumed that the distance between the top of the concrete and the bottom of the levelling nuts is twice the diameter of the anchor. It is possible to remove some anchors or change their diameter. Try to change the anchor diameter to 45 mm instead of 30 mm. You can see it changed. Look here. But these are not the usual design assumptions. Special cases may require the use of different anchor diameters in the same connection. Reset the anchor diameter again to 30 mm. Click the Add button. You must select Use this connection in tower support option to allow ASMTower to use the connection at the monopole base. Click Update. Click OK. Click Update. ASMTower found an input error. Click OK to close the error dialog box. Each error appears in the bottom list with a description. Double-click the error to open the dialog box where the error is located. Suppose the top cover of the reinforcement is 50 mm. Click Update. Click OK. Click Update. Look at the bottom of the monopole. You can see how the anchors are drawn in 3D. Click Analyze. Base connection is safe with a rating of 0.88. You see only the connection design in the report. Click Setting on the top tab. Click the Report button and check on the base connection. Click the Report button from the Home tab. A detailed calculation of the bolt anchor is added to the report. The figure shows the arrangement of the anchor bolt. Assessments on steel stress. Assessments on the pull-out from the concrete. Assessments on the anchor bolt development length with the foundation reinforcement. The required length is 1160 and supplied is 1300 mm. It's safe. Close the report. Click the Design drawing on the bottom tab. Table of appurtenances. Table of maximum reactions. Click the Export DXF button to save the design drawing in CAD file format. Type a name for the file. Click Save. The default CAD software will open automatically. Until it opens, check out the other charts. Deformation graph for the monopole under any load combination. Global moment graphs. Now the CAD software opens. The drawing includes a monopole geometry. It includes design notes, antenna table, reaction table,